Hello, and welcome to your statistics class. These notes can be found in my math lab under the tab that says Class Notes. You can, it's a PDF, you can print it out, and you can take notes along with me if you'd like. Here we go, we have a fun little Dilbert up here. And the beginning of statistics is mostly definitions and explaining what different words mean. Just make sure that we're all on the same page on that. So we're going to start with some definitions of some words that you might have heard of before and some that maybe you have not. Our first definition is the word data. Is a collection of observations such as measurements and survey responses. The singular version of the word data is datum. It's kind of like curricula is plural for curriculum, if you know those words. Next up, we have statistics. Is the science of planning studies and experiments, obtaining data, then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. And we'll hit a lot more on these words. These specific definitions will become more clear as we're going through this. A population is the entire group being studied. A sample is a subset of members selected from the population. For example, let's say that we wanted to do some sort of test, and we wanted to know the mean height of students at Long Beach City College. Well, the entire population would be every student at Long Beach City College. A sample maybe is my specific classroom. So it's a subset of the entire population being studied. Next up, we have the census. Is a collection of data from every member of the population. In reality, this is rarely something that is possible to do. If we could always do this, then that would be great. But usually there's a population that's so large and so diverse, it'd be nearly impossible to get every single member to gather data from that. And that brings us to descriptive statistics. Consists of organizing and summarizing data through numerical summaries, tables, and graphs. This is going to be the first 2/3 of the course is going to be descriptive statistics. These are things like how do you find the average, how do you find the mean, once you have data, how do we display the data in a way that's useful that other people can understand what the data is trying to say, and so on. The more interesting statistics is what's called inferential. Inferential statistics uses methods that take a result from a sample and extend it to the population and measure the reliability of the result. For example, what we're going to be doing starting chapter 8 and on is inferential statistics. That's sort of the goal of the class, is to get us there. These are nice and we can get good data from there, but inferential means that we're taking something from a sample and we're getting some data from that, some information from that, and then we're going to infer, or we're going to make not an assumption, we're going to make a connection to the full population, and then talk about how far off could we be based on this information that we have. And we'll talk about that all semester. That's definitely stuff that's coming up. Number 8 is a parameter. Is a numerical measurement describing some characteristic of a population, versus a statistic is a numerical measurement describing some characteristic of the sample. And this little chart down here, it helps sort of explain what we mean by that. So here's our population. This is the entirety of Long Beach City College, say. And what we do is we take maybe my classroom, which we'll show why that's a bad way of gathering data in another talk. What we want to do is randomly select from here and then come up with some information, meaning the mean. So in this case, the mean for a sample, it's what we call X bar. So, and that's the mean of a sample. Now, what we want to do is we want to use the mean of the sample to infer that we now know the mean of the population of the entirety of the Long Beach City College. So we can find the mean height of students in my class, and then can we use that information to say, hey, how close are we to the real mean of the entire population? Same here with this sample. We have a sample from a population, and once we get that information, we can now infer something about the population. And that's going to be the more advanced stuff starting Chapter 8 and so on. And chapters 5, 6, and 7 are nothing but getting ready for Chapter 8. Not that it's super difficult, it's probably a new way of thinking for many of you. Next up, our last definition. Oop, too high. This is sampling error. Sampling error, and you can read through the definition, but here's basically what sampling error is. If I use a sample from a population, obviously with that sample, there's going to be some error between the actual mean of the height of my class, my students, and there's going to be slightly different for the mean of the entire population. And that's what sampling error is. We know that there's going to be some error. How do we measure that error, and how do we contain that error? Again, you can read through the formal definition if you want. But that's basically what that is we are aware that there's going to be an error from the sample to the population, and we keep an eye on that. Let's do some practice. In a national survey, 72% of parents reported worrying about saving for college. Is this a so what we're looking for are these statistics, which is the sample, or these parameters, which is the entire population. Now, a national survey, they're usually not the entire population. So this is going to be a sample, which means the 72% is a statistic. Here, only 12 men have walked on the moon. That's the entire population of people that have walked on the moon, and unfortunately it is men. That might be changing soon. The average age of these men at the time of their moonwalk was 39 years, 11 months, and 15 days. Because the 12 men represent the entire population of people that have been on the moon, this is a parameter. Starting here and ending here. A study of 100 adults who used public transportation in San Francisco found that 86% of felt the system was reliable. This is definitely a sample. There's definitely more than 100 people that live in San Francisco, which makes this a statistic. The 86% is the statistic. Upon opening their box of Christmas ornaments, a family found that 4% of them were broken in the move. Well, this is their box of Christmas ornaments. That's the population. That makes this a parameter. If you guessed wrong, that's okay. This is new and kind of weird to think about. TER, parameter. All right, that's it for this first video.